Hello students, today we will solve one more question and the question goes like this. See, an electron falls through a distance of 1.5 centimeter in a uniform electric field of magnitude 2.0 into 10 to the power 4 Newton per Coulomb. Direction of the field is reversed, keeping its magnitude unchanged, and the proton falls through the same distance. Compute the time of fall in each case. Contrast the situation with that of free fall under gravity. So here we have three concepts: a concept of electron, another concept of proton, and then the last concept of free fall under gravity. When we are considering the case of an electron or a proton, we are changing the direction of electric field but not the magnitude. Direction changed, magnitude same. Okay, now let us come to the answer, to the solution, how we are going to find the solution for the given question. First of all, we will note down the given things in our question. First, it is given height of the fall 1.5 centimeter and the magnitude of electric field, that is 2 into 10 to the power 4 Newton per Coulomb. So these two things are not going to be changed, will remain unchanged. Throughout the question. If it's a proton, height is same, 1.5 into 10 to the power minus 2 meter. If it is electric field, it will be having magnitude of 2 into 10 to the power 4 Newton per Coulomb. And when we go for the other charge, it will remain same. Now we are considering the case 1. Case 1 is of electron. Okay, in case 1 we are considering electron. So what is the polarity of electron? Electron have negative polarity. So according to the principle of like charges repel and unlike charges attract, in a given uniform electric field, from where this electron will move to where? This is negative part of our electric fields and this is positive, and if we are keeping our electron here, this electron will move in this direction. And when we are reversing the polarity of the electric field, like positive on the above side, negative on the down side, and we are keeping a proton over here, this proton is positive, they will repel each other, but this will attract, so it will come down, fall towards the down. Same, negative will repel, but this positive will attract over here, so this electron will fall to downwards. Okay, so you have understood the diagram, how it is being represented. When an electron is dropped in upward electric field, it experiences a downward force. This is upward. See the direction of electric field, they are moving up. Okay, but our system of electron is moving downwards. So force is given as F equals to E into E. What is E? E is our Q, charge, magnitude of the charge, and E is electric field. Previously we have studied Coulomb's law and the concept of electric field also. So using these two, we can find a relation between force and electric field. What is that? that is force equals to Q into E. Okay, so this is what we are going to get. Now from the Newton's law, the law of forces, we know that force equals to mass into acceleration. Okay, force equals to mass into acceleration, and then our acceleration will be force divided by mass. Mass of what? We are considering the case of electron, hence mass of electron. Okay, now from this equation we know the value of force. From this equation we know the value of force. What is it? Force is E into E, and then that is divided by mass of electron. Hence we get the acceleration as this. Okay, now since electron is dropped into the electric field, its initial velocity u equals to 0. Like this is our electric field going from here to here, and this is our electron. It is kept here. Now after introducing the electric field, this is made to fall. Initially this electron was at rest, and hence the initial velocity is 0. So by this formula of motion, laws of motion for straight line, we have derived this formula. Okay, that is distance equals to initial speed or velocity into time plus half into acceleration into time square. Okay, so here distance is given as 1.5 into 10 to the power minus 2 meter, and initial velocity is 0, so the whole term turns out to be 0. Half into acceleration we need to find, and acceleration we got from the previous equation, and time we need to find. So what is acceleration from the previous slide? That is acceleration equals to force by me, where F is E upon me. Okay, so substituting this equation, like first of all rearranging this equation, this term is 0, so what we will get is S equals to half a t square. Now 2s upon a equals to t square, taking under root on both the sides, what we will get? We will get this t square as t only. So what is the value of t? It is 2s by a. Now from the previous equation, what is the value of a? A equals to E by mass of electron. Substituting this a over here, we will get this particular equation. See, I will write over here the equation we are getting: t equals to under root 2s upon E by me. Rearranging it, we will get t equals to under root 2s me upon E into E. Okay, so this is what we are getting, and here this is the formula. Now we are writing up all the given values. Here h is 1.5 into 10 to the power minus 2. Mass of electron, see this thing, mass of electron is 9.11 into 10 to the power minus 31 kgs, and mass of proton is given as 1.627 into 10 to the power minus 27 kgs. So here which mass is greater? Mass of proton is greater than mass of electron. Okay, substituting all these values, and after doing all the calculation, we got the value of time as 2.9 into 10 to the power minus 9 second. This is time for electron, 2.9 into 10 to the power minus 9 second. Okay, now we will move on to the second solution, the second case. What is the second case? Second case is we are taking proton and electric field is reversed. What about the magnitude? magnitude is same. Magnitude equals to same. Okay, again the proton will fall from up to down. Proton from up to down. Okay, so again we know that force equals to E into E. Here capital E is electric field. Electric field. Okay, when the proton is dropped into a reversed electric field, it experiences a net downward force, and we know that force equals to mass into acceleration, and from this equation we got acceleration equals to force upon mass of proton, and from the previous equation we got force equals to E into E, that is divided by mass of proton to get the acceleration. Okay, now again we will substitute all the values of E and MP to get our value for acceleration, and then again using the motions equation we will get the value of time required by a proton to come from the upper end to the lower end. Now see, since the proton is dropped into the field, its initial velocity is 0, and final we do not need in this particular equation. Again this equation is coming from the laws of motion in straight line. Okay, and by substituting all the values ut will become 0, and again doing the same thing which we have done for the case of electron, we found out T equals to under root 2 into h into mass of proton divided by E into E. Okay, so value of h is 1.5 into 10 to the power minus 2 meter. MP equals to 1.627 into 10 to the power minus 27 kgs. E's value is 1.6 into 10 to the power minus 19, and capital E's value is given as 2 into 10 to the power 4 Newton per coulomb. Okay, substituting all these values we get to know the time T of proton is this. Now let us compare the time of proton and time of electron in the same magnitude of electric field. Okay, I will write here same E. Okay, here we will get a relation that mass of proton is greater than mass of electron. Acceleration of proton is smaller than acceleration of electron as see here in red, as acceleration equals to force upon mass. Acceleration is inversely proportional to mass, inversely proportional to mass. Whenever mass will increase, acceleration will decrease. Okay, so and then time of proton will be greater than time of electron. Why so? Because see over here, this relation T equals to under root 2h by AP. Here time is proportional to 1 by under root A. So if we are increasing time by 4 units, acceleration should decrease by 2 units. They have like relation in terms of square. First is inversely proportional, and then second is they are squared proportional. Like if we are squaring up this term, we will get t square is proportional to 1 by a. Okay. So as the acceleration decreases, decreases, our time will increase. You can see it in the normal life when you are going by a scooty or a bike. If you are moving it slowly, from reaching from point A to B, let's assume that point A to B is 1 kilometer, you will take approximately half an hour. But as you will accelerate it by 5 units, you may reach within 20 minutes. If you will accelerate further, the time will get reduced. So more the acceleration, less the time taken. Okay. So one thing, don't consider this line. This is written in opposite manner. Here instead of proton, one should write electron, and this should be proton. This is miswrote. Okay, just make a note of it, correct it in your notebooks, don't copy it as such. But now the third thing which our question gave us, the third challenge the question presented in front of us was to understand the relation with respect to free fall. So let's go to this particular point. Follow up the yellow ink, but this is in contrast to the situation of free fall. This is in contrast, this is totally opposite. Why so? Because the time taken by an object in a free fall is independent of mass of the object. While studying gravitation, you all might have went through this thing. They have told us again and again that if we are taking up a feather, and a stone, okay, and in a closed system or in a evacuated system implies there is no gravity, like no gravity space, we are just throwing them in this no gravity space at the same time, t equals to t dash. The time by when they will reach to the bottom of this space will be t equals to t double dash. This feather will have mass which is very much lesser than the mass of stone. We all know feathers, leaf, cloth, they have very less mass when compared to a stone. Okay, a very small stone will also have greater mass than a feather. So when we are throwing these two in a lift, like a lift which is moving with a very high speed, actually shows a system of free fall, shows a gravity free system. Okay, whenever you are in a lift and it suddenly moves for a minute, like for not of course a minute, of course for a second, you will feel like floating in the space. That is like gravity free. In that such case, the mass is of no use, and here our system is independent of mass and it will fall according to the like anti-gravity rules, and they will fall to the bottom of the space in the same time. So come to the note, again follow up the yellow ink. Acceleration due to gravity is ignored in calculating the time of fall. When we were considering the electron and proton in the previous case 1 and case 2, we did not take in account the acceleration of gravity. And why did we do that? Because acceleration of proton in the given electric field is this. We have got this formula na, E by mp in the acceleration, using these formula like force equals to charge into electric field and force equals to mass into acceleration. So both are force. When we are comparing both the equation, we will get E equals to ma, and from this equation we can find out A ki value, and it comes around A equals to small e into capital E divided by mass. Okay, And we know the value of all the things. Small e is 1.6 into 10 to the power minus 19. Capital E is given in the question, that is 2 into 10 to the power 4 Newton per coulomb. And mass of a proton of a electron we can find out very, like, we know it, it's universal and it is same at every point. Mass of electron is 9.11 into 10 to the power minus 31, and mass of proton is 1.627 into 10 to the power minus 27 kgs. So we know the mass. Okay, substituting all these values in this particular given equation, now we will see that here, follow up the green ink, we will see the acceleration came around 1.9 into 10 to the power 12 meter per second square. What is the acceleration due to gravity? It is quite a small, very small value, that is 9.8 meter per second. Just see the relation, which is enormous compared to the gravity, the acceleration due to gravity, and the acceleration of electron will even be much greater. Why? Because mass of proton is more than mass of electron. When the mass is increasing, acceleration will be decreasing. The effect of acceleration due to gravity can be ignored, and in such this case we can ignore the effect of gravity. See one thing, this is 1.9 into 10 to the power 12. What is the speed of light? Whenever you are getting confused with the numbers, always compare a big number with the speed of light, because light we are observing in daily life. We see as soon as we switch on the bulb of our room gets lit. Okay, we do not need to wait for 5 minutes for our room to get lit. It gets immediately. No time delay is seen. Why so? Because time travels at the highest speed known in the universe. So this is more than the time speed, and this is a very countable number. We can count this number. Okay, so this is countable, but this is really tough to be counted. Such a huge number it is. So comparing these two things, we get to know the acceleration of proton in this system itself is so higher that if we will add or subtract g from it, there will be negligible changes. Acceleration of proton added or subtracted with acceleration of gravity will not make any significant change in the acceleration. No significant changes. So here we got the solution to all the three problems. Let's get summarized of the question. In this particular question, they asked us, first thing was how much time a electron will take from coming from the upside of a electric field to down, and then in the second we dealt with the proton in the same condition, only the polarity of our electric field was changed. Thirdly, we compared our gravity with the electric field for electron and proton. What we have seen here is mass, acceleration and time relation. Mass is proportional to 1 by a and time is proportional to 1 by a square. Sorry, 1 by a under root. Okay. So accordingly, we can find out if we are increasing mass, what will be the effect on acceleration, and if acceleration is being changed, increased or decreased, what will be the outcome with respect to the time. And when we dealt with gravity due to our gravitational force on earth is extremely small when we compare the acceleration due to a proton or electron in the given electric field. Hence, we do not introduce acceleration due to gravity whenever we are doing calculation for an electron or proton in a given electric field. Hope you got the idea how we solve this question and you have understood it. Okay, just go through this, and here we have used a few basic equations like force, mass, acceleration relationship from your 11th standard, and then this distance, initial speed, acceleration and time relationship again from your 11th standard. So just get updated and get refreshed of these formulas, which will be helping you here as well as in the upcoming sections also. So that's all for today's class. Bye bye.